Okay. So, um, so uh, we're gonna be doing WebGPU. WebGPU is a graphics API, sort of like OpenGL, Vulkan, and stuff like that. It allows you to draw graphics like cubes. I mean, it's not very easy. I'm gonna show you some examples on the WebGPU site. If you search, you can find the site. WebGPU was made for Rust, so that's why I'm gonna be using it, as it's like the most compatible with it. Even though the name stands for web, like on Apple web stuff, you can also use it not just on the web. So yeah, that's a good thing. So here are some examples. For example, there's a game engine, Bevy, the most popular Rust game engine, which is made using WebGPU. It's very good. I've used it before. Maybe I'll use it on the streams one day. Another thing which is also popular is Valorant. It's a Rust MMORPG. It's very good. I've spent a lot of hours playing it. The game looks amazing. So yeah. There's some other stuff here. Basically, WebGPU is very powerful. It is faster than OpenGL, but slower than Vulkan. So I'm gonna be doing it today. What is a graphics API? Graphics APIs basically allow you to draw graphics. That means everything, like boxes, lines, cubes, meshes. It's difficult because all graphics API are very low level. So I am gonna be following this, except for the first part, because this uses Winit version 29, as you can see here. It's pretty difficult to see because it's red on red, but that's fine. But it uses the 29th version of Winit, which is not the latest, so it's not preferred to use it. So we're going to be using version 30, and for that I found someone actually rewrote the code for it. I sort of did something already myself, like the default app, but I'm probably going to be rewriting this to follow this. For now, let me just quickly see if there's something I would like to change about how I did things. So yeah, first of all, in the state file, I'm gonna use WebGPU. I'm just gonna copy this because this is everything that I need. And I'm gonna create a new struct called state. Also, oh yeah, I love this one. This is, wait, what is the name of this song? Yeah, Dummy. Okay. Also, I like this code that I found here. If you can see, this is like from the original GitHub. I like this part because it doesn't use lifetimes. It makes it way easier to work. It's a little bit different because it uses a static lifetime, which can have some issues, sorta, I guess, but probably in the stuff which I'm planning on using this for, it's not gonna have any issues. Let's see if I'm speaking. I mean, it seems to be like half of my volume. It's fine. It's fine. Okay. So let's see what it does here real quickly. So it has an application. Oh, oops, wrong program. I have an application state. For the state struct, it has a surface in it, which is type of WebGPU. Oh, it already has surface. Okay, so it's a surface with a static lifetime, which means that it's going to exist for the entirety of the program, so until like it closes. We have a device. I'm going to talk about that later. Actually, no, I'm not going to talk about it. We're going to go through the documentation. So, yeah. Because I'm not the smartest programmer, so I can't really yet. So WGPU config, surface configuration, size, physical size, basically the size of the screen. Physical size, type of U32, and window, and arc pointer to it. Oh, does it not get which window to use? Import init window, yeah. And also need to import arc. Okay. So we're gonna implement some functions for our state. For now we're just gonna do public function new, which is gonna take a window as a parameter, and return itself. I'm just gonna do 2D. So we have a simple state. I'm not gonna be filling out any of this right now. This is for the surface chapter. For now I'm just gonna be making the simple window so it can open itself. So in our app, I'm gonna rewrite this a little bit because I wrote this myself, but because I'm gonna be following this documentation, it's gonna be better if I make it as close as possible. So in here we're gonna be needing a reference to our state. We're using, is it gonna, yeah, I need to make this a public struct. So this is gonna use state. I'm probably gonna have to also do, yeah, import create state. Actually, I'm gonna import everything from there because I'm gonna be using all of it. So in here, we're gonna create a public function app, probably new, yeah. It does new, which returns a self, and the self is none. I'm gonna have to specify that the state is none. So this is how we create it. There are some other, actually I'm wondering, is it gonna use the functions? Yeah, resize render, it uses them there. So for now I'm gonna remove them from here. I am gonna leave process input here though. This process input gets called in window event. Window event basically goes through each event. That can be redraw, keyboard input, resize, close requested, and stuff like that. So when it's a window keyboard event, I just pass in the key event into this function. It's just that it's easier to write it like this. You don't need to do it. Yeah, I'm gonna say it like that. So okay. If we go to window event, actually no, here. Yeah, we need to create a new window. So it's gonna be let window be equal to event loop, create a new window. With okay, I am gonna change something here. I'm gonna pass in window attributes of type window attributes, and here in state I'm gonna also have window attributes, and in here I'm just gonna set it. Yeah. Oh, forgot the comma. So that here later on I can do self.windowAttributes.clone and unwrap. This way I get a window. Then using the window I'm gonna call the self.state.new. Oh wait, no, it's gonna be equal to sum. Yeah, state new, and we pass in the window. Okay, let's see. So in here, redraw requested. Okay, we're gonna have to do some of that later. Function about to wait. I'm probably Yep, I'm gonna just copy this here, because dot window. Oh yeah, because I don't have a function which implements the window. It should just return the window, right? Right, let me find it here, yeah. It's a public function in our state, which get window is a better name. So just get a reference to self. We return a window. This, oh, a reference to a window we return. Okay. So it does this, self dot window. Okay. So this is nice. We can call dot get window here. Redraw requested. Okay, we're gonna work with this later. Oh, another good one. Yeah, Fallen Down. I love Toby Fox. He made such great music for Undertale. So, if we go to main, yep, set attributes is no longer correct. We're gonna do app is not gonna derive from default because that's gonna cause a lot of issues. So it's gonna be app new, and yeah, we just pass in the window attributes. This should not work technically, right? Yeah. Some problems, thread main panicked, and yeah, makes sense. So now let me close all this. So we did window event, keyboard input. Let's see, something else we need to copy from here real quick. All of this are gonna be done in another function. Device, window event. Yep, this seems... Actually, this is a weird thing. I don't think I run the app like that. I do event loop.run app. Maybe I should try how they do it there. So, let nothing be equal to event loop dot run app borrowed mutable app. Yeah, but that's not good because I am using, yeah, I use this for error logging. I mean, I can probably just do this. I don't see why I would need to do it like this, maybe to clear the event loop afterwards, so I can't use it again. Yeah, probably. But you mistyped the programming tag in your symbol. Really? Oh yeah, I did. Okay, let's change that real quick. Not here, I'm gonna change it like this. Yep. Yep, this is good. I think now it should be correct, yeah. Thank you for noticing that, Nicole. I really appreciate it. So now, let's go to here. Yeah, so I think everything is done. We can now start with the actual documentation. So there isn't really anything interesting here. Let's just go to the surface. I'm probably gonna mostly go over... Yeah, it's in a sync function, right? I don't think I made it in a sync. Oh, no. Huh. How does it do it without async? Does it use async here? It doesn't. Oh, that's weird. Okay. So... I'm still gonna be like reading most of the stuff from here, but copying the code from here as it's better. Yeah. So let's go to here. Okay, and this is gonna be better if I do it like this. Yeah, it's fine. Yeah, this is readable. Let's see, let's go to our state and finally start working on our state function. So first we're going to need a window reference, an arc pointer, so we're going to create a new arc pointer from the window. Then we're going to have to get the size. It's usually called inner size, but I guess normal size is also fine. So inner size. Then we need to create the instance. Here it does everything in one function, which I am not a big fan of. That is why I am gonna do it like it does here, so different functions. The instance, so the first new two things that we're about to discover is the instance and the adapter. Oh, and surface is basically what we draw to, so like the screen, you can say so. So in this case, we're gonna see. The instance is the first thing you create when using WebGPU. Its main purpose is to create adapters and surfaces. Yeah, surfaces is to draw on, adapters is a handle for actual graphics card. You can use this to get information about the graphics card, such as its name and what backend the adapter uses. We use this to create our own device and queue later. Let's discuss the fields of request adapter options. Let me... yeah. So here we can see how it's created. Basically, instance allows us to specify which backends and stuff we get. In this case, if we are not using WebAssembly, this basically says not running Arch. I get target Arch as WebAssembly 32. I'm not going to be doing this because I am not planning on running this on web. So I'm just going to make public function create state instance. Just going to return an instance, WebGPU instance. Oh, I'm just going to write it like this. So yeah, it creates a GPU instance. Yeah, just do instance new. The instance description is going to be instance descriptor with the backends. We're going to use the primary backend. And everything else by default. I think it is suggested that we... oh wait, no, it has been updated. Oh, I guess then yeah, there is no use for it. Okay. So now we set the instance to create state. Oh, I need to do self.create. Also, I should make this not a public function, as it might mess up things in the future. Create state instance. Okay, what's wrong? Cannot find in the scope. Oh, yeah, so I forgot to do that. We're also going to create a surface, which is created using the instance we just made. It is going to be equal to instance. I misspelled instance. Instance. Dot create. This is a weird one. What? Oh. Oh, I thought this was the original mice on Venus. No, this is like some recreation of it. Yeah, I don't like it. I'm gonna remove it. I just got suggested that I should add some... oh. I need to ban someone real fast. Okay. Sadly, I do not want to get a lot of viewers for a low price of some amount of price. So we're gonna create a surface using the window arc dot unwrap. Oh, and don't forget this, of course. Wait, it allows me to create a window from an arc? I mean, an instance. From, yeah, I need to do a claw, of course, because this is a pointer, and I need to get a value from it. Let's see. Next thing is the adapter. So create a state adapter, which we're gonna pass in the instance and the reference to my surface. So now let's create the actual function. Function create state adapter takes in our instance as an instance and our surface as a reference to surface, and returns an adapter. So let's see how we create an adapter. An adapter, we can specify a few different options. So let's see which ones they are. Okay, so we request adapter option. Let me actually do it like this. Yeah, this is better. So request adapter options. Our power preference is going to be the default one. Most of the stuff is going to be default. There are actually different types of it. Yeah, it specifies here. So it's low power and high performance. Low power is, I mean, yeah, both of them make sense. There's no need for me to specify, but I'm going to use the default one. So like, depending on what machine, it's going to be like, right now I want to use low power, or I can use high power, and so let's see. Then we set our compatible surface to our surface. I could just pass the surface to right. Oh yeah. Force fallback adapter false. Actually, I think this creates it differently. Create adapter instance dot request adapter. Yeah, it has been updated. That's what I thought. Instance dot request adapter. The options are web GPU request adapter options. Web GPU request adapter options. Our power preference is again the default one. Our compatible surface is the surface we made. So it's just some reference to surface. And force fallback adapter false. Okay, here we're also going to do block on, which I think makes it so we have to wait. Found for opaque type implementation, sure. Yeah, I think I have to derive something. Or maybe not. Let's see. Yeah, I need to use the poster. Let me just quickly go to my things and use it. So here, then specify that we want to use poster and we want to use block on and feature extensions. Don't forget this. So. This waits on. Actually, yeah, let's Google it. Just so I know for sure. Poster block on. Block the thread until the feature is ready. Okay, so because this requires some time to make, and before we continue, because we're going to need to use the adapter in the future, we have to wait until it's finished making it, and then yeah. It's mostly so we don't have to use multi-threading stuff right now. And so we can, and this is also so we can use the static thing. So, next is, after the instance and the adapter, the surface is part of a window that we draw to. In order to draw directly to the screen, our window needs to implement raw window handle. Has raw window handle trait to create a surface. Fortunately, Winit's window fits the bill. We also needed to request our adapter. Let me check something real quick. Yeah, okay. This should work, right? Watch time, just so I can check. Yep, 0 sec. Oh, I have spent 0 seconds watching my own streams. Wow. I think this is broken. Probably is. Okay, let's see. Let's use the adapter to create the device and queue. The features field on device descriptor allows us to specify what extra features we want. For this simple example, I've decided not to use any extra features. Does it explain what device and queue are? I think it doesn't. Basically, they allow us to set different features, like how we want to draw stuff, like limits. Usually it's default limits, but you can make them bigger, which is usually not required. Just always do them on default. Doesn't really explain them here, doesn't it? Huh, maybe a little bit lower? It should explain them. Okay, yeah, it doesn't explain what it is, sadly. What is device and queue? Yeah, basically queue is some random commands. Not random commands, like a command if you want to draw something, or some other commands, and it's just like a queue of them, basically. And device allows us to do stuff. We're probably gonna encounter it later on. Right, probably. So let's create our device and queue. So we go here, function, create state device and queue. We're gonna probably use both of them. It requires our adapter, a reference to the adapter to be more precise, and it returns the device and the queue like this. Get space. So we do adapter dot request device. The description of the device is WGPU device descriptor. Device descriptor. Our required features are just going to be default, and our required limits are just also going to be default. And our trace path is going to be none. I think it explains what trace path is, so that's good. And title, label, none. We also don't have to forget to set this again block on and unwrap. So the WebGPU descriptor, what is the problem? Missing struct. Also this is supposed to be limits. Memory hints. WGPU, memory hints. Okay, yeah, there is a default version, so I'm just gonna set it to that. I have no idea what this is. Probably explains it. Hints for memory allocation strategies. Yeah, I'm probably not gonna be going into this. Let's close these functions. Oh, there. Yeah, exactly. I just can't anymore. The features field on device descriptor allows you to specify what extra features we want. For this example, I've decided not to use any extra features. We can get features by doing adapter.features or device.features. For example, one of the features I've used before is, let's see, okay, can you just, no. Yeah, polygon mode line, and basically allows you to, instead of filling all the polygons, you just only draw their lines. I think I actually have some images of how it looks somewhere stored, so I can quickly show it. Probably no, but I have some pictures of how it looks without working, which is pretty cool in my opinion, but I cannot seem to find pictures of it actually working. Explain to me why I spent the last 3 hours perfecting my movement script instead of learning more low. That happened to me. I spent 1 month on my movement script, but now I can happily say that it's perfect. I think actually in this server I showcase how it looks. If we go a little bit up. Yeah, this is how it looks. So you can, yeah, I didn't share the normal picture, but if you select the features line, it's only gonna draw the lines of the polygon, so I'm gonna actually fill in anything there, which looks pretty nice in some cases. Okay, I'm gonna put this back here. I love Creator. Lena Raine is such a good artist. Made amazing song for music for Celeste and amazing music for Minecraft. Okay. So after device, let's see here. What do we need after device? Surface caps. I don't like to say the word caps because it's capabilities, which is stupid. Why do you shorten surface capabilities to surface caps? But I guess people do that for some reason. I don't know. And chicory. What is this? I don't know what that is. Oh, what is the problem with the adapter? Oh, I spelled adapter. Okay. Okay. And it's probably config self create state surface config. So we pass in our size and surface capabilities, and using that, let's create this gets in size as physical size of type Q32 and surface capabilities as surface capabilities. Yeah. So in here, okay. So we have to return the surface config. Let me add surface configuration here. Yep. This. Oh my god, what the hell happened? Nothing interesting. Okay. So let's see what surface configuration is. I think the things that I should talk about is here we're defining a config for our surface. This will define how the surface creates its underlying surface texture or textures. Will be used. Render attachment specifies that the textures will be used to write to the screen. Okay. The format defines how surface textures will be stored on the GPU. We can get a supported format from the surface capabilities, which we are doing here, yeah, or in my code here. So we iterate through all the possible formats of surface capability, and we're finding the one which supports sRGB format. I think I'm gonna have to actually change this to sRGB later. What is our... sRGB and ARGB. Visual difference worth... Okay, what is sRGB? It's a standard RGB color space that HP and Microsoft created, blah blah blah. Wait, how do I use transparent images though? Huh? Shouldn't be like, is RG... Oh, I guess it's only sRGB then. It's a reference to a reference. And I do not feel good about this line here. I have a feeling it's gonna have that it's gonna turn some problems later on. But fine. Let's see. Next, with their height. Okay. Format defines how. Okay. Present mode uses WGPU present mode enum. Where is this present mode? Oh yeah. Auto no vsync. Does it use no vsync? I think I'm gonna actually use this just in case, because I know that this will be supported anyways. Frame latency 2, that is how many frames are gonna be pre-rendered. And then we can just return it, right? Let's see what it does here. Surface.configure, device and config. Okay, yeah, that makes sense. We have to actually set the config we made using the reference to our device and the reference to our config. Okay, in the end, we return ourselves. So basically, surface, device, queue, config, and size. Oh, also window, which is a window arc. So this is done. This is probably the biggest amount of code that we're gonna see like in one function. It's just that creating stuff. A lot of people call this boilerplate, but I wouldn't really say it's boilerplate in this case, because it's actually useful to change some of those values. For example, in Vulkan, there is boilerplate, where there's like only one specific use when changing the value might be useful, and you have to like spend 50 lines of code on it, and yeah, that is boilerplate, and I do not like that. Okay, so now we go to the new functions. Actually, wait, let me see how it does stuff here real quick. So it's an async function run. So here, wait, where? Public async function run. State application created the same. Any async stuff here? Nope. So when running the function, we do block on. We just don't, we need to also use bolster for this, so block on. Yep, I think this is fine. Because if window ID, actually, do I do this check? Because I don't think I do this check. Yeah, I need to do this check because I need to know, because if I'm using like multiple windows, it's nice to know if I'm accessing the correct window. Let's just say it like this. It shouldn't be window, right? Yeah. We first need to get the window, which we do like this. And then using that window, we do this. Okay. We can also pass in the window ID, I guess, there. Oh, it's not window, it's get window. But no, I'm not gonna do that. I don't need it, and I'm not gonna do it. So let's see. So we finished the creation of our state. Let's see, new functions. So first, we're gonna do resize. So this is some WebAssembly stuff. We don't need to worry about that. Dependencies, can I just go here? Okay. If you want to support resizing in our application, we're going to need to reconfigure the surface every time the window size changes. Yeah, because surface by default does not bind to the window, so if we make the window a bit bigger, the surface will stay the same size and it's gonna look weird. So let's create the resize function, which should basically just reset the surface size. It's a public function. Resize, so we want to change values in our struct, so it's gonna be a self and mutable, which basically allows us to change the value. Maybe a new size, winit, GPI, physical size. Wait, no, this is just gonna use physical size, right? Let me check real fast here. Yeah, just physical size. It's not gonna return anything. Self.size is gonna be equal to new size. Self.config dot width is gonna be equal to new size dot width, and self.config dot height is gonna be equal to new size dot height. So we're gonna reconfigure our surface. The device is gonna stay the same, but the config is gonna be the new config. I mean, not the new config, it's still gonna stay the config ourselves, we just change the size and height. And yeah, this should be printing. I don't really see the point of debugging that. Okay, input. I've already done the input check. Let's go to update. Update, is that a useful what? Huh? I don't think I'm gonna need update. Yeah. All the updating is done. Wait, where even is all the updating done? It should be done here. Right? Like, checks events. It runs the app. I think window event is run every frame. Emitted when the event loop is about to block and wait for a few. Okay. Okay, so we cannot use the. Is there like function? Yeah, there aren't many other functions I can use. Wait, what do I use for updating then? Huh? Because window event is only run when we send an event to the window. Oh, which is gonna be every frame, right? Because we're gonna do resize first of all. Yeah, I have to do this. Window event resized. So in this case, physical size. And we're gonna call our function, so it's gonna be self.state dot as mutable because we're gonna be changing it. Unwrap dot resize and physical size here. And don't forget the comma, of course. Let me separate this. The same is gonna be done for. Is there like a window event update or something? Nope. I mean, it's still gonna be run every frame because we're gonna be drawing every frame, so I guess we can count on this to be like our update loop. Not the best option, of course, but I mean, we can. So we're gonna do self.state. We also borrow this as mutable. We're gonna do that a bit later, the render function. Dot render, it doesn't show up, dot unwrap. I actually don't need this, this is a one-liner. It's fine without this, just put a comma. So now here, in state, I create a new function, it's a public function, render, which takes a mutable of self in just that. So this is where all of our cool drawing is going to be done. So let's see. Where's the render method? Oh yeah, the render method will return an error, a surface error, in the case that it will fail. So you can either return nothing if it's okay, which is what we want, or it will return a WGPU surface error, which basically means we failed at drawing to our surface. If everything is fine, we're just gonna return okay. And this is gonna be in the end. Because if something is not fine, then it's just gonna return an error and it's never gonna get to this. So, yeah. So, in our render code, first we create a texture, a variable, output, which is gonna be the frame that we're gonna render to. So it's a self surface.get current texture. Our view is going to be this. So we also need to create a texture viewer, just texture, not viewer. So it's going to be. Oh, we also need to, because this returns a result, we can do unwrap or default, or there's a shorter thing, it's just a question mark. And it does the same thing, it just, yeah, shorter. So we're gonna return a texture, create a view from WebGPU texture view descriptor default. Let's see. Yeah, it does all the same stuff. I'm gonna follow this sort, I guess. We also need a command encoder to create the actual commands to send to the GPU. So using this, we're gonna send the commands to the queue. For example, we want to draw 6 indices, vertexes, with those colors. It's gonna go there and then it's gonna process it later on. So for that, we need to make an encoder to actually encode our commands. It's going to be command encoder, command encoder descriptor, and it's going to have nothing but a label, which is just going to be render encoder. Wait, what is this melody called again? This is like Style? Oh yeah, Style! Oh my god. The best song ever. Let's close this. Oh, it also does it like this. Ah, I guess it's fine. We are gonna be dropping render pass. It's just that in this thing, we take control of the view, I think, and the encoder. So we won't be able to use it. So what we do is we put this in these things, like a block. Like an expression can be a block. We did that like yesterday. And basically on the end of this, it's gonna drop all those values from being held in here, and yeah. I don't really know why we need to make it like a variable, but it's fine. Okay, so we begin render pass. It's WGPU render pass descriptor. So the label is gonna be, again, just a render pass, nothing specific. Color attachments, they're gonna be, I forgot what color attachments are, we're gonna see later on. Again. So view is a borrowed view, dissolve target is none, ops, WGPU operations. So we load an operation of type clear, which is going to be a WebGPU, which takes in a WebGPU color. Let's make it like this, so it's 0. And the alpha is going to be this. Okay, so depth stencil attachment none, occlusion also none, and timestamp rights also none. Just do this. Let's see. Now we can get to clearing the screen, a long time coming. We need to use the encoder to create a render pass. The render pass has all the methods for the actual drawing. The code for creating a render pass is a bit nested, so I'll copy it all here before talking about its pieces. First things first, let's talk about the extra block. Borrows, yeah, okay. So here you can see that. Okay, wait, no, this is something else. You can't call encoder finish. The block. He doesn't really explain anything. Oh yeah, wait, what's going on? First, let's finish this code and run it, because I have a strange feeling that it's not gonna work. Self.q. We're gonna submit to the Q a command, exactly what I said, because the Q holds all the render commands that we want to pass in. So in this case, we're just gonna iterate through each encoder. Oh my god. Output dot present, and then we just draw the output. Okay, so this should work. Probably no. So many possible errors. And it does work. Well, look at this. We've created a window which clears the color I specified. Where's the state? Here. That makes me wonder, if I can set the alpha value, does that mean that I can make it transparent? Let's save this and rerun our project. Nope, it does not. I mean, makes sense because from what I got, we created an sRGB texture which does not support transparency, but transparency is probably covered somewhere in the future. Showcase creating GIF spawn. It doesn't seem like it should. It's probably gonna cover it at some point. There's no way that it doesn't cover transparent textures. So for now, let's just put it back to normal. 1.0. So now let's see what all of this actually does. So some of you may be able to tell what's going on just by looking at it, but I'd be remiss if I didn't go over it. Let's take a look at the code again. Render pass descriptor only has 3 fields: label, color attachments, and depth stencil attachment. Label is pretty self-explanatory. The color attachments describe where we're going to draw our color to. We use the texture view we created earlier to make sure that we render to the screen. Basically, in texture view, because it creates a view from the output, and the output is set to the surface texture. So this way, texture view specifies that we are going to be drawing to our surface. The color attachments field is a sparse array. This allows you to use a pipeline that expects multiple render targets and only supplies the ones you care about. We'll use depth stencil attachment later, but we'll set it to none for now, so they're probably not going to expand right now. The render pass color attachments has the view field, which informs WebGPU what texture to save the colors to. Yeah, just like I said, that it's gonna make a command with the encoder, and it's gonna send those textures to the view, which again basically does it to the surface get texture. Yeah, it's pretty self-explanatory so far. This is the cool thing though, these operations. Let's see, so it gets the current texture. The resolve target is the texture that will receive the resolve output. This will be the same as view, unless multi-sampling is enabled. We don't need to specify this, so we leave it as none. Multi-sampling, I don't know what that is. Probably, let's see real fast. Multi-sampling. I saw a modification of super sampling algorithm that is more focused on age anti-aliasing. Multi-sampling times 8. Oh, I think I get what it does, sorta. I mean, I'm gonna have to sort of implement it in the future anyways, so yeah. Let's see. The ops, or operations, field takes WebGPU operations object. This tells WebGPU what to do with the colors on the screen specified by view. The load field tells WebGPU how to handle colors stored from the previous frame. Currently, we're clearing the screen with a bluish color. The store field tells WebGPU whether we want to store the rendered results to the texture behind our texture view. In this case, okay. We're clearing the screen with a bluish color. The store, yep, here, field tells WebGPU whether we want to store the rendered results to the texture behind our texture view. We want to do this, because if we didn't do this, so we did, I guess, yeah, discard, it's just not going to do anything. Let me quickly close the program, run again. It's just not going to draw anything. Oh, this looks cool, I guess. But yes, discards the thing. So let's set this back to store. 'Cause It's not uncommon to not clear the screen if the screen is going to be completely covered up with objects. If your scene doesn't cover the entire screen, however, you can end up with something like this. Yeah, this is pretty cool looking. And the way this is done is because we don't clear our screen. So it just gets drawn onto itself multiple times, thus producing these cool things. If you may run into validation errors if you're running an older version of Vulkanized game. Well, I've actually had this error before. I think when I used WebGPU like a month ago, somewhat, I tried it out real quickly and I had the same error. And I was for the longest time ever, I was trying to figure out the solution, and I didn't know that it actually said down here, like if you're getting validation errors and stuff like that. So the pipeline, I think I'm gonna do this for tomorrow, as I've already spent a lot of time today doing this and it doesn't seem as anyone is here. So I don't see the point, and this is actually where the interesting part begins. This is where we finally get to draw our really cool figures.